Well, now that you've seen the video on the origin of E and how it was created, invented, then you should know a little bit about this guy who created this, and this basically tells everything that I told in the video. However, this is not nearly as detailed and doesn't really take you through the process. So, yeah, this is a very quick summary that's not detailed at all. Let me ramble for just a second, and what I'm about to say is in the latter part of this paragraph or sentence. This part of the sentence right here, but let me just talk for just a second. This will start making sense in a minute. If I wrote this, if I wrote log of x equals 2, you could solve that, I hope. What number is that right there? That's a 10. So it's 10 to the second power equals x. So 10 squared equals x, and so x is equal to 100. Okay, not that big a deal. If it's not written, it's a 10. Well, now that we've introduced the number e, we're going to call it a natural log, ln. It's backwards because in a lot of European languages, French, Spanish, Italian, possibly German, I'm not sure, they put the adjective after the verb, so it's sort of like log natural. And so if I said natural log of x equals 2, and I said, hey, what am I pointing to? I'm not pointing to a 10 right now. I'm pointing to an e. And don't treat e like a variable. Please don't treat e like a variable. We know what e is. E is, and I'm going to show you exactly what it is in the calculator, and you just saw it in the other video anyway, but e is 2.718281828 right there. See? Okay, so e squared equals x. So e squared equals x. And we can find out what e squared is. You know how to do this. So take your calculator, e squared, and I'm a 2 decimal place kind of guy, so 7.39. And again, let me just tell you why this is so practical. Again, banking formulas, they use it all the time. Natural logarithms are used in so many other applications as well. I couldn't even begin to list them all. So that was just a random example. Let's look at number 1. Okay, there's a glare on my table. Isn't that driving you crazy right there? Right there. I'm going to fix that. I'm going to fix that real quick. Let me put down something. I'm going to find something. That's bothering me probably more than it's bothering you there. You'd never know that glare was there. Now that big yellow notebook's going to bother you, isn't it? Okay. It's important to note just the number 10 and log are inverses, so are e and ln. And so, because I may not have room to work everything out on here, I'm going to use some scrap paper. If you want to squeeze it in here, that's fine. But let's go ahead and start with number 1. Here we go. E to the x equals 4. Well, they're inverses of each other, meaning this. If I start with e to the x equals 4, just like I would rewrite the other stuff, I can rewrite this one. Just as, and just bear with me for a second, just as if I said 2 to the x equals 7 or whatever, you would rewrite it and go log base 2 of 7 equals x, and you would do that and you'd figure it out. We're going to do the same thing here, but now I'm not going to use log because I have an e. I'm going to use a natural log. Natural log of 4 equals x. Now you're probably thinking, where'd your e go? Where'd my e go? Well, here it is. It's understood. If you want to write it, you can, but I'm not going to. Now, don't get crazy and draw a heart on your paper. You'd end up back where you started. We have isolated the x. The whole point is to solve, which means find out what x is. So you take your calculator, you lay it down where there's a huge glare. I don't know where the glare is on your desk, but anyway, natural log of 4. And don't be asking me where it is. There it is right there, ln 4. Rounded to 2 decimal places, 1.39. That is equal to x, so there's number 1. Okay, let's do number 2. Number 2 is almost exactly the same. E to the x plus 2 equals 3. Excuse me. Alright, so we're going to rewrite it just like we did the other. So the natural log with a base of e that you don't have to write, just like you didn't have to write that 10 on the other ones, equals x plus 2. Don't panic. Don't subtract 2, not yet. Find out what the natural log of 3 is. Natural log of 3 is we'll round that up, 1.10 equals x plus 2. Okay, well, let's subtract 2 from both sides. And we get negative 0.90. You can put the 0 or not, doesn't matter. Okay, so there's number 2. And this goes back to some notes that you had about a week ago. whenever it starts as an exponent, you turn it into a log. Whenever it starts as a log, you'll turn it into an exponent. Okay. Here goes number 3. 4e to the x equals 5. Now, what are we going to do with that 4? He's bothering me. Well, he's bothering me too. Let's divide by 4. We'll cancel those out. We'll divide those out. So e to the x equals 5 over 4. That's 1 1/4. Well, what now, Mr. Reader? I'm lost. And a lot of people say, well, I can do it while you're doing it, but then I get lost. Okay, fine then. Well, let's start all over. What would you do from the beginning? Obviously, you divide by 4, because you want this to end up looking like this. You knew how to do this one, I hope, or you do now. So you need to turn this into something you know how to do. And then when you get to here, you say, well, how do I solve it? Same way we did this, only it's just a different number. Turn this into a log. Natural log with a base of e, 1.25 equals x. Find out what the natural log of 1.25 is. Tap your calculator. Back in the day, they used to have mathematical tables. Students would have books and books that just had table after table of all these values in there, and they had to figure them out from that. Okay, here we go, number 4. Now, what I'd like for you to do is mute your computer. Seriously, mute your computer. Try to do number 4 on your own, because I'm not going to say too much during this problem for 2 reasons. I want you to do it on your own, and I'm losing my voice. Yeah. We'll start by dividing by 12, and then I'm going to stop talking. I hope you're not just copying what I have. There's number 4. Okay, again, I hope you didn't just copy that. You're only hurting yourself. Alright, here's number 5. Number 5 is almost exactly like number 4. What do you want to do first? Good call. Now what? You know what? I'm going to stop right there. I'm not going to finish number 5. I'm not. Here's what I want you to do. I want you to do number 5 on your own. You can pause this video right now. Do number 5 on your own, because I don't want people just to kind of keep copying what I'm doing. So, pause it, finish it on your own, and then before you move on to the back, check with me. Make sure you have number 5 correct. Okay, here's number 6. Natural log of e to the x equals 10. Now there are 2 explanations for this. I'd love to go ahead and blurt out the answer, but I'm not going to. But notice that it started as a natural log, and since it starts as a natural log, you're going to have to turn it into an exponent. There's an understood e down here. Well, Mr. Reader, isn't there already an e down here? Yeah, but that's not the base. That's not the number that would normally go here. So e to the 10th power equals that mess, all that mess right there. So let's just write down exactly what I just said. E to the 10th power equals all that mess, e to the x. Now, we can get ourselves all in a tizzy trying to figure out what's going on with this, and there's another way we can solve it from here, but don't panic. The answer is about to become really obvious. E to the 10th equals e to the x. If you could somehow, and there is a way how, if you could somehow eliminate your e's, what would you get? If your e's were gone, what would you get? Hopefully you just said the answer. I'm not going to tell you what the answer is, although you probably just said it. I'm going to go a different route on this. I'm going to start back from the very beginning, and I'm going to do it a different way. I'm going to do it in blue just so it doesn't kind of blend in with everything else. Okay, so I got right up to the end and didn't tell you the answer, but I want you to see a different way. The natural log of e to the x equals 10. I hope you remember some of the properties that I shared with you last week about how if you have a coefficient, it becomes an exponent. Well, it can go backwards too. So if you wanted to, you can take that x and put it in the front. You have x natural log of e equals 10. Oops, put an x, my bad. It's 10. Well, we can find out what the natural log of e is. Now, I'm going to show you in the calculator, and then I'm going to explain why that's the answer. The natural log of e, where's my e button? There's another one right there. It's the division key if you have one of my calculators. Is 1. So we have x times 1 equals 10. So there we go. There's our answer. Let me explain why the natural log of e is 1. This basically says e to what power will give me e. Well, anything to the first power will give me itself. Well, there's one exception to that, that'd be 0, but e to the first power is e, which is why this was a 1, which is why the answer is just 10. Just wanted to point that out. That one, I made it harder than it was because I wanted to sort of uncover some of the little secrets behind it. But let's move on. Let's go to number 7. Actually, number 7 is much easier. Number 7, in blue, natural log of x equals 4. And here's what we're going to do. We're going to turn it into an exponent. It is in logarithmic form. Let's turn it into an exponent. E to the 4th equals x. So e to the 4th equals x. And here's the thing. A lot of people get stuck here and they go, I don't know what to do. Yeah, you do. Grab your calculator. Find out what e to the 4th is. 54.60. $54.60. That's what x is. Okay, number 8. The natural log of 4x. I put it in parentheses. I don't know why, but it's perfectly okay. What do you want to do first? I'm going to let you go ahead and do it. What you doing? Taking your E, drawing your heart. There we go. This is one of those problems like number 5 I'm not going to finish. I would like for you to come and check with me when you are done with this problem, or when you're done with these notes, and make sure you got number 5 and number 8 correct. Need to find out what e squared is? I'm stopping there. That went too far. Okay, number 9. Almost done. What fun. Natural log of x minus the natural log of 7 equals 2. My word, Mr. Reader, we got a mess. Dang right we got a mess. Let's fix it. When you're subtracting logs, what should you do? Let me clarify. This is not in logarithmic form. Yeah, you can look at it and say, well, I see logs. I do too, but that doesn't mean it's in logarithmic form in its purest form. We have 2 logs when we need there to be 1. We need this to say log of something, something, something equals 2. Now, the problem is we don't know what that something, something, something is. Well, when we're subtracting logs, we divide. Okay? So now we do e squared equals x over 7. I'm not finishing number 9 either. It is up to you to come and check with me and make sure you have 5, 8, and 9 correct. The mood hits me. I may not finish number 10, but we will definitely start it. 2 natural log of x plus 2 natural log of 3 equals 4. I want to show you 2 ways of doing this problem. Way number 1. Oh, look, I have a coefficient in front of a log, whether it's a regular log or a natural log, it's there. And you can move it up and let it become an exponent. So we have natural log of x squared, natural log of 3 squared. I know what that is. You know what 3 squared is, but we're going to go with it. We get that. Now, when we add logs, we really multiply. So, x squared times 3 squared, well that's 9. 9 times x squared is 9x squared, and that is equal to 4. You know what, I think I will finish this one. And then I'm going to show you the other way too. E. How do we know to do that at this step? Because it's in logarithmic form. Logarithmic form has one log. So e to the 4th equals all that mess right there. So e to the 4th equals all that mess right there. And we find out what e to the 4th is. You grab your calculator. I'm actually not going to waste my time because I just found out a minute ago. Okay, so it's 5460 equals 9x squared. What now? What would you do next? You're solving for x. You got to get x by itself, so you will divide by 9. Now I do need my calculator for this. I know it's 6 and almost 0.7, but not quite. 54.6 divided by 9. X squared. 6.06 repeating-ish. However, if you want to be realistic about it, it's actually not that at all. E to the 4th was this, and then we divide that by 9, so yeah, the 6 doesn't necessarily really repeat, but we're going to lose some accuracy in rounding in the end anyway, so let's just keep going. Square root both sides. We'll square root that. Whoops. We'll square root our last answer, and we get 2.46. Now, don't get happy and say, yay, I'm done. I want to show you another way of doing number 10. I'll keep this quick. Here's number 10. Again, that rhymed. 2 natural log of x plus 2 natural log of 3 equals 4. In the past, we have said, well, I have a coefficient, I'll move it up, and that's great. And you can do it, and we just did it, and we got the right answer. However, look at this. If we divide every term by 2, then those will divide out, and then we are left with a problem that's not as unreasonable as you might think. In the end, we're going to get the same answer. Same thing. We're adding logarithms, so we're going to multiply. So x times 3 is 3x. And then we draw the little heart. E squared equals 3x. E squared equals 3x. And I'm just going to stop right there. Let me point out something, though, just because I'm in the mood to. This and this are the exact same thing, only this is the square root of everything here. If I was to take this right here and square root both sides, that'd give me e squared, and that'd give me 3x. In the end, I'm going to get the same thing. It's just a different way. Just wanted to throw that out there. I wanted to show you that. Okay. There are some problems on the back that you need to do. I will let you know which ones they are. Enjoy. Come check with me on number 5, 8, and 9.